So we're going to take a look at this fundamental trigonometric identities quiz. I've given this back, but some students struggle with it a little bit. Some people did very well, so we're going to kind of try to get everybody on the same page. The premise of this is to make one side of this equation become exactly the same as the other side without adding things to both sides or multiplying things by both sides. You can only really mess with one side and only deal with one side, and then we're going to make this side identical to the other side using trig identities. Is pretty much so. This is called a trig verification, identity verification, or a proof if you want to call it that. So we're going to take a look at the top of this quotient here. We have 1 plus tangent x. Useful trick when you're solving problems like this is to make everything in terms of sine and cosine. Sometimes that works, sometimes it doesn't, but this is one that I think is going to be a good candidate for that, so let's give it a try. We have 1 plus sine x over cosine x. If you recall the quotient identity, tangent x is the same thing as sine x over cosine x. On the bottom, we're going to leave it as we have it, sine x plus cosine x. Okie doke. Now what you see here though is I could write 1 as 1 over 1, and what I would like is a common denominator of these two fractions on the top of this quotient here. So what I'm going to do actually is, instead of saying 1 over 1, I'm going to write that as cosine x over cosine x, because technically cosine x over cosine x is the same thing as 1. And now I'm going to go ahead and add this other fraction here, sine x over cosine x. And then again I'm going to put this over sine x plus cosine x. Now what I'm going to end up getting is a single fraction, because now I have a common denominator on the top here. So I have basically cosine x plus sine x all over cosine x. This is the top of my quotient here, so this is the fraction we have on top. And on the bottom what I have is sine x plus cosine x still. And what you should realize is I actually could write this as a fraction as well. I could put this over 1. So I got a fraction on top and a fraction on bottom. When you divide by a fraction, what you're technically doing is multiplying by its reciprocal. So I'm going to show that step over here. I'm going to come over here and multiply the top by the reciprocal of the bottom, which basically means just flip it upside down. So we got 1 over sine x plus cosine x. Alright, so this gets ignored. We basically have used this, so we're just going to multiply across. So we have cosine x plus sine x times 1, which will just give me cosine x plus sine x. And then we got the bottom, cosine x times sine x plus cosine x. What's going to happen though is that the top here is going to cross out with the bottom here, because technically they're identical. So I have a step on top and a step on bottom. We're going to cross them out. We have these terms that are the same. What's going to be left is 1 over cosine x. That's what I'm going to get. And then what I have is 1 over cosine x, and that's of course the same thing as secant x. That's a reciprocal identity. So we say this 1 over cosine x is equal to secant x, so I have this as the answer, and that's actually identical to what I have right here. That's my secant x. It's a lovely arrow I've drawn, but there it is. It's the same thing, and that's what you need to be looking for. So we're going to come over here, scroll down, and keep working on this. We have number 2. Alright, so let's take a look at this. Again, we have two fractions. I would like a common denominator typically to get this started. So I'm actually going to multiply the top and the bottom of this fraction by, let's see, where's my pen tool? Get it back if I can. Alright, let's try it again. Alright. Pen tool keeps disappearing on me. Yeah. So let's take a look at number 2. We're going to get a fraction. We're going to multiply the top and bottom by sine x, because what I need is a common denominator on the bottom. So this is what I'm going to do. I'm going to multiply this by sine x and this by sine x. And I need this because this is going to give me a common denominator. So I have sine x times sine x. Let's multiply this in. And that's going to give me sine squared x. Alright. And what I'm going to have here is sine x times, sine x times 1 plus cosine x, we'll say. That's what that is. We're going to multiply this times this, and I get this. Now, I need a common denominator. I know that sine x times 1 plus cosine x, so here's already the sine x, so I actually have to multiply this by 1 plus cosine x. Over here, we're going to do that top and bottom as well, 1 plus cosine x. Alright, so I'm going to multiply this times this. We're going to FOIL that. I really like that acronym. We're going to distribute that properly. So what's going to happen is I have 1 times 1, so I'm going to get 1. I'm going to have 1 times cosine x, so I got another cosine x. We got cosine x times 1 again, so cosine x. And then cosine x times cosine x, which is going to give me cosine squared x. And what you're going to notice here is now I have a common denominator. This is sine x times this is sine x times this. So basically this is a single fraction already. And there's a trig identity hidden in here. We have sine squared x plus cosine squared x, and that actually, when you add them together, will just give me 1. So I'm going to take this 1 and I'm going to add it to the 1 that I already have, and that's going to give me a 2. Now I count my cosine x's. I got cosine x and cosine x, so I got 2 of those. So I'm going to add 2 cosine x here. And this is all over this denominator that we already have on here, which is sine x times 1 plus cosine x. So I'm going to take a look at this fraction, and I'm going to factor out a 2 out of the top. So I'm going to take 2 out, and when I do that, I'll get 2 times 1 plus cosine x. Again, all over sine x times 1 plus cosine x. And what you're going to see happen is that we have a term on top that's the same as the term on bottom, and they cross out. So what I have now is basically 2 over sine, or this is actually 2 over sine x. I should put a sine x here. And we're going to say this is 2 over sine of x. And that's going to be the same thing as 2 times 1 over sine of x. And 1 over sine of x is the same thing as cosecant. So this becomes 2 times cosecant x. So this is what we've determined, what we've derived from the left side of the equation. And if you come around here and notice, what we have here is the same thing as our answer. So that's the proof there. This is the work or something similar to it that you should show. So if you didn't get that the first time around, go ahead and have a look at that and study that and make sure you understand everything. And then we're going to go ahead and look at number 3 while we're here. Again, we have 2 fractions, and we need a common denominator. So I'm going to make this a little messy than the previous problem. At least I'm going to try to anyway. So let's have a look. Keep losing the pen here. I'm going to blow this up. See if we keep it going. Alright, so I'm going to copy this. And I got 1 plus sine x minus 1. And I'm going to multiply the top and bottom of this by sine x plus 1 and sine x plus 1. And then I got a minus. And I got this other fraction here from the problem, 1 over sine x plus 1. And what I'm going to do is actually multiply the top and bottom of this by sine x minus 1. And the reason I'm doing that is, you notice, if I multiply this and this, it'll be the same thing as this and this. That will give me a common denominator. So let's go ahead and multiply this through. We got sine x plus 1 times 1. So basically this is a sine x plus 1. Right? And we got this, sine x plus 1 times sine x minus 1. That is a difference of squares. If you remember your difference of squares formula, what you're going to end up getting after you distribute that is going to be sine squared x minus 1. That's all that is. So again, we have our minus sign, and then we're going to multiply this top part by 1. So it's going to give me sine x minus 1 over this times this is the same difference of squares, so it'll be the same thing as what we have here, which is in fact sine squared x minus 1. So what we have now is a common denominator on both of these fractions, and I can write this simply as sine x. What we were really doing is this here. So we're going to say sine x plus 1 minus, in parentheses, sine x minus 1. And then we're going to put this whole thing over sine squared x minus 1. If I distribute this negative in here, that's actually a negative sine x. And if I distribute this negative over here, a negative times a negative 1 is a positive 1. So that's really what I'm looking at here. I have sine x minus sine x, which makes nothing. And then I got 1 plus 1, which is actually 2. So I'm going to get 2 over sine squared x minus 1. And then I'm looking at this answer over here, what I'm trying to get, and this is secant squared. Secant is a reciprocal of cosine, not sine, so I actually need to get rid of this sine squared if I can. What I know is a trig identity. I'm going to write it up here. I know that sine squared x plus cosine squared x is in fact equal to 1. That's the first Pythagorean identity we've derived. And if I look at this this identity here, I can actually subtract sine squared x from both sides. What that's going to give me basically is cosine squared x now will be 1 minus sine squared x. That's pretty much what that means. Okay, so this is what I want to turn into cosine, because I need a cosine to figure this out here. And what I have is sine squared x minus 1. This right here is not the same thing as what I want. But I do realize something, that this has a positive sine squared x, that's a negative sine squared x, that's a negative 1, that's a positive 1 up here. So I'm actually going to just factor out a negative 1. That's all I have to do. So I'm going to factor out a negative 1. And what that's going to give me is going to flip the signs on these guys. This one's going to be negative, this is going to be positive when I figure this out. So what's going to happen is I got a positive 1 and now a negative sine squared x right here. That's what's happening. So this is actually the same thing as this. So I can write this as simply 2 over, or negative 2. Now I'm going to move this negative up here with the top number. I can do that over cosine squared x, because this is the same thing as cosine squared x. This will actually give me the same thing as negative 2 times secant squared x. That's the same thing. 1 over cosine squared x is secant squared x. So this will be what I come up with from here. And this, of course, is the same thing as your answer up here. So this problem is done. So make sure you study that one for future reference. Let's go ahead and get to the last question. There's several ways you could do this. There's several ways I've seen it done by students. This is the way I've chosen to do it, which I think is easiest for me, but probably not for you. However you've done it, that's okay, as long as it's correct, of course. But what I'm going to do is actually look at here. I have cosine x and tangent x on this side of this particular binomial expression is what this is. We got a term here and a term here. But this has a cosine, and so does this. This has a tangent on this side, and so does this. So I'm going to factor out a cosine x tangent x. And what that's going to leave me inside this parentheses, if I take out my cosine x and my tangent x, is basically secant squared x. That's what I have. If I take out this cosine x and take out this one of these tangent x's, because this is tangent x multiplied by itself 3 times, this is going to leave me with a square when I take one of these out. So this is going to be minus, and then simply tangent squared x. Now, what I remember from my identities again, my Pythagorean identities, is that tangent squared x plus 1 is equal to secant squared x. This is a trig identity. And I look here and I see secant squared x, and I see secant squared x right here. So basically, I can substitute this in for my secant squared x. So I can substitute it in there. So what I'm going to do is that I got cosine x times tangent x, and then for secant squared x, I'm going to write tangent squared x plus 1 instead. And then of course I got minus tangent squared x. What you're going to notice here is that tangent squared x minus tangent squared x makes 0. This is gone. With this, they cancel each other out. So what I have is 1. And now that I have this 1 right here, basically this whole thing just became 1. So simply 1 times cosine x tangent x. This is all I really have is cosine x tangent x. But cosine x tangent x right here is actually equal to cosine x over 1 times sine x over cosine x. You should know by now that tangent x is the same thing as sine x over cosine x. So what happens is these cosines will cancel out, and then I get sine x over 1, which is simply equal to sine x. This sine x is the answer. It's the same thing that I was after from the beginning. So this is proven here. This is what I'm looking for, or something similar to it, when I'm grading your papers. So thank you for watching this video. I hope it was helpful. I hope you study this and keep checking in with me to see if we can look at more videos here. All right, appreciate it.